All right, so now we're looking at solving trig equations, and we looked at this a little bit in our modeling, but now we're going to look at it just for equations and think about connecting this back to the unit circle. So if I wanted to know when 2 cosine x plus 1 is equal to 0, well, I can see that that's on my graph in 2 different places if I look from 0 to 2 pi. Which makes sense with what I know about my unit circle, that I have 2 places generally that cosine is equal to 0, but now I've stretched and shifted the graph. So seeing this, I've got 2 places that are symmetric around pi, but I can also think about solving this algebraically. So I subtract 1 to the other side and divide by 2. That tells me that cos x is going to be negative 1/2. Well, I know that from my unit circle, I've got 2 places that cos x is negative 1/2. So here's negative 1/2, that's my short value, so that's my tall angle. And cosine is negative, so quadrants 2 and 3. Well, that makes sense because between pi over 2 and pi, that's quadrant 2. Between pi and 3 pi over 2, that's quadrant 3. So I know that this reference angle, the size of that angle, so my matching size over here, my theta reference, is pi over 3, but this angle in quadrant 2 is going to be pi minus pi over 3, 2 pi over 3, or it's going to be pi plus pi over 3, which gives me my 4 pi over 3. Wanting to find any of the other values, I'm just going to add multiples of 2 pi. So from here to this one, that's going to be my 2 pi over 3 minus 2 pi, or my 4 pi over 3 minus 2 pi would take me here. So I can just add or subtract multiples of 2 pi once I have my 2 different quadrant angles. That means we would always have infinite solutions, so we're going to give you a restricted domain, which tells you exactly how many we're looking for. So that's what we're going to use going forward to solve trig equations.